Okay, Ji, we will start in 1 minute, right? So that rest of the people they can join. Okay, Ji. So what we have seen that in the N-type semiconductor, whenever a pentavalent impurity is being added, so due to that, plenty of free electrons they will be created in the conduction band, and there will also be some free electron due to the whole electron hole pair creation, right? So this means there are a lot of free electrons in the conduction band, and the electrons or here, which are the free electrons in the conduction band, they are called the majority carriers in case of N-type semiconductor, right? And the holes which are available in the valence band, they are called the minority carriers the in case of the N-type semiconductor, right? So this all happens due to the addition of pentavalent impurity, and the pentavalent impurity over here is antimony, right? Now let's suppose if we add a trivalent impurity, means adding a trivalent impurity, tri trivalent impurity, and trivalent impurity over here is basically one of the trivalent impurity is boron, boron, and boron is represented as B out here. Right? So what happens that when we add boron in the okay, so when we add trivalent impurity, so what happens that we have B, we have side, we have Si, we have Si, and we have Si, right? So what happens? We have one covalent bond which is being formed over here. So we say one covalent bond, another covalent bond, another covalent bond, and then we have basically, in case of boron, we have three valence electrons, and due to these three valence electrons, we will not have the fourth covalent bond that can be made. And when the fourth covalent bond cannot be made, so this means a hole is being created, right? The hole is, again, which I have told you before, the hole is basically a void of electron. That electron is not present over here, right? So this means again, this means that we have the number of holes which are created. It is according to the number of impurity atoms which are being added in the intrinsic semiconductor. And this addition of trivalent impurity creates another type of extrinsic semiconductor which is called P-type, P-type, P-type semiconductor, right? And in p-type semiconductor, what we have basically free electrons in the conduction band, and we have plenty of holes. They are being created due to the addition of trivalent impurity. And there are some few holes due to the electron hole pair creation, right? Now, the holes over here in p-type semiconductor, they are called the majority carriers, which are available in the valence band, right? Uh, and uh, and we have the free electrons which are in the conduction band. They are called the minority carriers, and which are available in the conduction band, right? Are you with me? Question.
Yes, sir.
G. Question.
No, sir.
बात समझ में आ रही है?
जी सर।
Yes, sir.
Okay. Okay, so now what we have seen, we have basically the intrinsic semiconductor and we have the extrinsic semiconductor. Extrinsic semiconductors, they are of two types. One is called the p-type and the other one is called the n-type. Now, if we take the intrinsic semiconductor and dope one side with the trivalent impurity and dope the other side with pentavalent impurity, so what we are going to get, right? So if we dope one side with trivalent impurity, the pure intrinsic semiconductor, and dope the other side with the pentavalent impurity, right? So if we have this block, if we add a trivalent on this side, and if we add a pentavalent on this side, right? So what will happen? Now this side will become, we will have plenty of holes. They will be created over here. This means hole will be the majority carriers, and plenty of free electrons, they will be created on this side. Right? And very few free electrons, they will be available over here. And very few holes, they will be available over here. Right? Now, whenever the p-type, because this is the p-type, and this will become the n-type. Whenever they come together, when they are become close to one another, what will happen? That the free electrons on the p side, they will be start moving towards this side. Right? They will be start moving from the n side to the p side. And when they will start moving from the n side to the p side, what will happen? That the n side will be losing the negative charges. Right? And whenever it loses the negative charges, so this means there will be some ions which will be created, and those ions will have a positive charge on these ions. Right? So positive ions will be created whenever the electron moves from the n side to the p side. And whenever these electron moves towards the n side, what happens? That there are some ions which are being created on the p side, because the electrons, they are being added over here. So the atoms will have a net negative charge over here. Right? Are you with me? बात समझ में आ रही है?
Yes, sir.
Yes, sir.
So this
Yes,
means
sir.
whenever the electron moves from the n side to the p side, so on the n side, the positive ions will be created. On the p side, negative ions will be created. Now, if we see what happens on the band level, so let's take a look on the band level, that what is happening. That on the p side and on the n side, if you see, one thing before going further on. So if you see on the p side, we have added a trivalent impurity, right? And on the n side, we have added a pentavalent impurity. Now, whenever in the valence band, you have less number of electrons, so this means that the energy in the valence band are actually having at a higher energy level, because the force of attraction on the last valence band is less. So this means the electrons, they will have a higher energy level as compared to when you are comparing with a pentavalent atom. This means that the force of attraction on 5 electrons will be more as compared to the 3 electrons which are in the valence band. So whenever there are 3 electrons in the valence band, so this means the 3 electrons in the valence band will have a higher energy level as compared to 5 electrons in the valence band of the pentavalent impurity. So the 3 electrons, they will be actually at a higher energy as compared to the 5 electrons in the valence band of any atom, right? So due to that, what is happening? That due to that, what is happening? That whenever this situation takes place, so we have a situation, something like this, that
सर
the question.
जी सर हम तो पढ़ते हैं अगर वैलेंस शेल में इलेक्ट्रॉन बढ़ते हैं तो न्यूक्लियर पोल उन पे बढ़ती है तो यहाँ पर तो मतलब यहाँ पे जो पी टाइप वैलेंस बैंड इसमें 3 इलेक्ट्रॉन है तो इस पे न्यूक्लियर पोल क्यों ज्यादा है वो एन टाइप वाले जहाँ पे 5 इलेक्ट्रॉन है सर
देखें, मैं तो आपको यही बात बता रहा हूं कि पुल वहां पे ज्यादा होगी जहां पे वैलेंस इलेक्ट्रॉन ज्यादा हैं, ठीक है? बात समझ में आ रही है ना?
जी सर
अब जहां पे आपके पास 3 इलेक्ट्रॉन्स हैं वैलेंस शेल में, तो उन पे जो फोर्स होगी वो कम होगी एज कंपेयर टू दैट ऑफ जहां पे आपके पास 5 वैलेंस इलेक्ट्रॉन्स हैं, ठीक
जी
है?
सर बिल्कुल
आज सब ये बात ठीक है?
जी बिल्कुल सर
जब आपके पास पुल कम है 3 इलेक्ट्रॉन्स के लिए, तो उसका क्या मतलब है कि उनके पास ज्यादा एनर्जी है, वो हायर एनर्जी लेवल पे हैं एज कंपेयर टू जब आपके पास 5 इलेक्ट्रॉन्स हैं वैलेंस बैंड में।
जी सर
बात समझ में आ गई?
बिल्कुल सर
So this is the point, that whenever this is the situation, so what will happen, that on the p side the conduction band, on the p side the conduction band and the valence band, they will be actually a little bit having higher energy as compared to the conduction band and valence band on the n side. बात समझ में आ रही है?
जी सर
ठीक है जी. So whenever the electron starts moving from the n side, this is the n side and this is the p side, right? This is our conduction band, this is our valence band, and this is again our conduction band, and this is our valence band, right? So as you can see, there are lot of free electrons on the n side, and there are very few holes on the n side in the valence band. Then there are plenty of holes on the p side, and then there are very few free electrons on the p side. Now as you can see, there are plenty of free electrons on the n side. So what happens, these free electrons, they cross the n side and they move into the p side. When they move into the p side, so what happens, that they lose energy and they drop into the holes over here in the valence band, right? Now whenever this happens, so this means a lot of them, they move from here and they go into here into the valence band, right? Okay ji. So due to that, what happens, that we say that the positive ions are being created on the n side and negative ions are being created on the p side, right? बात समझ में आ रही है जी?
Yes, sir.
Yes, sir.
Are you with me now?
Yes, sir. Yes,
So,
sir.
so due to this, what happens that whenever this situation take place, so this means most of the high energy electrons which are on the n side, they cross into the p side and get into the valence band on the p side, right? Now, due to this, what happens that as the high energy electrons, which were on the n side, they have already went into the p side. So this means the net energy of the conduction band on the n side, it has lost its high energy free electrons or the majority carriers. So due to this, what happens that the net energy of the conduction band gets lowered, right? And when it gets lowered, so this happens that, let me just redraw it. So when this happens, so when this happens, so this means most of them, they are getting into the holes over here. So what happens now that the net conduction band energy level is now lower than the p side conduction band, right? And when it is getting lower, so this means now the conduction band on the n side is at a different energy level as compared to the conduction band on the p side. This is the p side and this is the n side. And similarly, when the conduction band is getting to a lower energy level, the band gap between the conduction band and the valence band is not going to change. It remains the same. So this means our valence band is also getting to a lower energy level, right? So due to this, what happens? Due to this, that now a barrier is being created because the conduction band on the n side is at different energy level. The conduction band on the p side is at different energy level, right? So once this has happened, so what we say, this becomes an energy hill, right? Okay, ji. Now, when we look into the crystal lattice itself, so what we say that an electric field is being created due to the positive ions and due to the negative ions over here, right? And this electric field, which is being created between the positive and the negative ions, this actually does not allow the free electrons which are being left over here to cross the electric field, right? So when we look from the latest perspective or the crystal perspective, we say that there is an electric field which is created over here and which is normally being called as the barrier potential, right? And when we take a look from the the conduction band and valence band perspective, like the atomic structure itself. So we say that an energy hill is being created because the free moving electrons from the n side, they have already crossed into the p side, and they get into the valence band on the p side. So they have lost their energy on the n side in the conduction band, and the conduction band gets into a lower energy level. Due to this, an energy hill is being created, and now to get the free electrons onto the p side, what we need to push the free electrons up the energy hill so that the electrons can overcome this energy hill, right? So without any potential, we can't do it, or without any force, we can't do it, right? So due to this, the free electrons on the n side, they are unable to get onto the p side, right? So therefore, there are two things. One is called the energy hill from this perspective, and then there is the barrier potential, which is from the crystal lattice prospectus, right? So this is the thing which you probably, I think you might have seen it, but not in this way, because it is giving you the clear idea that what is happening inside the semiconductor P side and N side, what is happening. Any question up till now? कोई question है तो पूछ लीजिए. Anyone?
No, sir.
Okay. Now, now the region over here in which the barrier potential is being created, this is called depletion region, right? This is called depletion region. Now, depletion region is a region which does not have any majority carriers, right? Or any carriers, because it is the region in which we have just got the ions, or we have the electric field which is being created, and it is depleted of the majority carriers, because we do not have any carriers in this region. Because on the p side we have the holes as the majority carriers and free electrons as the minority carriers. On the n side, we have free electrons as the majority carriers and holes as the minority carriers. So, okay, now if this semiconductor, is it made up of silicon, as which we have seen up till now? So the barrier potential, is normally 0.7 volts, right? And in case of silicon, if it is made up of germanium, the barrier potential is normally 0.3 volts, right? Okay. So depending upon that, whatever material we are using, and depending upon that, we have this is the situation. Okay. Now, whenever we have this P and N type, they are being created on the same crystal lattice. This Pn is normally called as P-N junction, right? Now, P-N junction is whenever P is on one side, N is being created on the other side, it is called P-N junction. And the P-N junction is normally being taken as P-N junction diode, right? So from this, we will be actually looking at that how the PN junction actually works, how the PN junction actually behaves, and how we can bias them, how we can bias in the positive direction, how we can bias it in the negative direction. And okay, and I think so this is good enough for today. Okay, ji. So this is just
Yes,
the
sir.
introduction. Again, what I will do, I will upload the soft form of the book on the Google Classroom. So you people can have the idea that what we will be going through and what we are looking into it. So that's it from my side. Any question, you are most welcome to ask. The question, anyone?
Sir, kindly repeat that.
क्या-
Energy,
जी क्या रिपीट करूं?
energy hill वाला sir.
अच्छा जी, okay. Okay, let's take a look at what we have said. Whenever we have the crystal lattice, when we dope the semiconductor uh, when we dope trivalent impurity on one side and pentavalent impurity on the other side. So what happens? We are creating p side on the one side and n side, n type on the other side of the crystal list. So on the n side, we know that we have plenty of free electrons, which are created in the conduction band. And we have plenty of holes, which are created on the p side in the valence band. And now these are basically the majority carriers. And the holes on the n side and free electrons on the p side, they are the minority carriers. Whenever these two p and n side come together, the free electron, they start moving towards the p side. And when they start moving towards the p side, so this means the n side is actually, or n type is actually losing the free electrons which are moving from the n side to the p side. So on the n side, what happens that positive charges are created because the n side is losing free electrons, and we are having the negative charges, they are created on the p side. So due to this positive and negative charges, an electric field is being created, and that area is basically called the barrier potential. And this is also called the depletion region because it is depleted of the carriers from the p side as well as the n side. Okay, with this, what we have, when we look into the band perspective, or the conduction band and the valence band perspective from the n side and p side. So what we have that we have the electrons on the n side which are in the conduction band. They start moving from the n side and they go into the p side. When they go into the p side, they lose energy, and once they lose energy, they go into the valence band on the p side, right? Now, as the high energy free electrons on the n side, they move towards the p side. So this means that what happens that they lose the high energy carriers in the conduction band on the n side. So this means the net energy level of the conduction band on the n side, they lose the energy. And when they lose the energy, what happens? That the net energy level is now down from that of the p side, and due to this the energy hill is being created, right? Because the conduction band on the n side is at lower energy level as compared to the conduction band on the p side. So if you want to move now the free electrons from the conduction band of the n side to the p side, what we need to push the free electrons up the energy hill, because the conduction band is at a higher energy level on the p side as compared to the conduction band on the n side, right? So we need to push the free electrons if we want to move the free electrons to move towards the p side, right? So therefore this energy hill is being created, right? And this energy hill cannot be crossed unless and until we provide some force to it. And how we will do it, we will see in the next lecture, that when we provide some biasing. And when we provide some biasing, what will happen, that is coming up in the next lecture. Okay ji, any question?
एक्सक्यूज मी सर
जी
सर हम बात करते हैं जब एंटीमनी जो पेयर करते हैं हम सिलिकॉन के साथ,
जी
तो सर एंटीमनी वैलेंस शेल में 5 इलेक्ट्रॉन होते हैं, मतलब उसको ऑक्टेट रूल पूरे करने के लिए 3 और इलेक्ट्रॉन्स चाहिए सर।
3 क्यों चाहिए उसको, 4 चाहिए?
नो सर, ऑक्टेट पूरा करने के लिए 3 चाहिए उसको सर, ऑक्टेट
लेकिन
रूल होता है
कोवेलेंट
सर।
बॉन्ड बनाता है ना वो।
तो सर कोवेलेंट बॉन्ड बनेगा ना सर वो, अगर वो 3 और एटम मतलब सिलिकॉन के अपने साथ लगाए तो उसका ऑक्टेट रूल भी पूरा हो जाएगा सर।
तो वो
इंस्टेड
अगर
ऑफ
वो 3 लगाएगा, बात सुन ले, अगर वो 3 लगाएगा तो क्रिस्टल का जो लेटेस्ट स्ट्रक्चर है ना वो खराब हो जाएगा। उसको अपने इर्द गिर्द जो है वो 4 ही लगाने होंगे।
अच्छा सर,
ठीक है, तो वो आपने क्रिस्टल का जो स्ट्रक्चर है वो तो नहीं डिस्टर्ब करना ना। अगर वो स्ट्रक्चर डिस्टर्ब हो जाएगा तो फिर तो वो अपनी सारी जो है वो फॉर्म ही, क्रिस्टल फॉर्म ही खत्म कर देगा सिलिकॉन। तो इसीलिए उसमें जब इम्प्योरिटी ऐड की जाती है तो वो हर एक से एक एक लेता है ताकि वो स्ट्रक्चर ना खराब हो। ठीक है जी। और इसी वजह से
ठीक है
जब
सर।
पेंटावेलेंट ऐड किया जाता है तो वो अपना एक जो है वो छोड़ देता है, बाकी जो है सबसे एक एक ले लेता है। तो इस तरह कोवेलेंट बॉन्ड इन कांटेक्ट रहते हैं। अच्छा आगे,
ठीक है सर।
बात समझ में आ गई?
जी सर।
ओके, any other question? We are having less than a minute. The session is going to end. कोई और क्वेश्चन तो नहीं है जी?
No, sir.
Okay जी, thank you. That's it from my side. And see you next week then. ठीक है जी, thank you.